Now we will talk about winds. Wind velocity for sure plays a very important role in transports of pollutants in the atmosphere. The most winds happen with tornadoes. Tornadoes have the highest wind speeds up to 200 miles per hour, which is almost 90 meters per second. That's a really very high velocity. Average ground level winds are about 10 miles per hour, which is 4.5 meters per second. Calm winds are less than 2 miles per hour, which is 1 meter per second. They are barely noticeable and often reported as calm. Wind speed increases with elevation. So because the ground friction slows wind at the surface. But when we go up, and you can always realize this when you go on a high rise building in Dubai and go in a balcony, you will find that the upper you go, the more wind you have. The planetary boundary layer is the region below 500 meters where ground friction is significantly affecting wind speed. Stable atmosphere, weak vertical movement resulting in lower wind velocity. And we know when it happens, when we have subadiabatic. If we have superadiabatic, we have unstable atmosphere where strong vertical movement leads to higher wind speeds. In the afternoon, there are higher wind speeds, though because the ground level winds are typically stronger in the early afternoon due to increased stability and mixing. It's also self-limiting winds, which are high winds, enhance vertical and horizontal mixing, balancing temperature gradients, and stabilizing the atmosphere. In neutral stability, where it's equal to the lapse rate, the adiabatic lapse rate, the winds greater than 6 meters per second tend to create neutral atmospheric stability, reducing the chance of rising air columns. Wind direction is critical for determining the impact on local environments. So, for example, if the wind direction is mostly blowing from the sea towards Dubai, you will have a different impact than if the wind is blowing from Dubai to the sea. So this, for example, will determine where you will put your industrial area in Dubai. You don't want to put industrial area where the wind will come and completely take all the time the emissions on the city. Pressure systems, you have high pressure zones or low pressure zones, and they are created by large-scale atmospheric instabilities. Low pressure systems are often associated with major storms and can overpower local wind effects. We talked about mountains, valleys, and shorelines earlier. Also, the effect of night cooling. And the valleys, also cold air flows downhill following the direction of streams and rivers. So, daytime valley winds, sun heats one side of the valley, causing air to rise and create rotating flow along the valley axis. Upslope and up-valley flows occur but are generally weaker than night flows. Talked about the mountains and how they could be a barrier. Basins trap air masses and impede low-level winds. Sea and land breeze, that happens during the day. Land heats faster than the ocean, causing cool air from the ocean to flow inland, cooling coastal cities like Los Angeles. While land breeze at night, the land cools faster than the ocean, causing the air from the land back over the ocean. So in the morning, the wind will be going this way. So it will be going up. It goes from the land to the ocean, but then down goes from the ocean to the land, but then it reverses during night. So it goes this way, where the land goes into the ocean and then it goes the other way around. So we call this sea breeze and land breeze. Sea breeze, and we call this land breeze. And this has a very big impact or coastal cities. Windrows is a very important graphical representation that all of you need to understand. So this is a typical windrows. Here we have east, west, south, north, and we get divided the 360 degrees, and we get representation. You can see here, let's look at this one here. This goes with this legend to show wind speed, the big one, more than 10.82 meter per second, and the small one is less than 1.55 meter per second. What does this show? It doesn't show that the wind is blowing north, but the wind is actually blowing from the north. This is what this means. So if we look at this, we're saying the prevalent wind here is coming from the north. And based on our readings here, we can see what is the typical wind speed that we have blowing from here. This windrows we can always draw based on years of data, not just 1 or 2 hours, but we can put it for 1 year, 3 years. Usually we do it for 5-year data. Where do we get this? We get this from weather stations. Where are weather stations? Usually at airports. So you will find that Al Ain Airport will have one, Sharjah Airport, Dubai Airport, Al Maktoum Airport, you have Zayed Airport. All the airports will have a weather station that they take measurements of the winds, and they use this to draw windroses like this one. Also in colors, not only in black and white. So we've seen that inversions play a very important role in air pollution and air transport. So stable air in inversions prevent vertical buoyant motion, reducing both horizontal and vertical dispersion of pollutants. So in other words, if you have an inversion, you really do have bad air quality. Why? Because whatever you are emitting stays next to you. It doesn't go anywhere. There are 4 types of inversions. You have cooling from below. That's the one that we described earlier. That's the most common and occurs during nighttime cooling. We have heating from above, often in high pressure systems with thinking air masses. We have warm air over cloud air. This is when you have downslope airflows to the lee side of a mountain. So you have large mountain, and then you have warm air over cold air that comes in the surface. Or you have cold air under warm air when you have the drainage inversion in valleys, especially in winter. So these are the 4 types of inversions. You have subsidence inversions, elevated inversions from 1,500 to 15,000 foot, formed due to sinking air in high pressure systems, commonly in sunny, low wind areas. You have valley inversions. Cold air drains into valleys at night, leading to persistent inversions in winters. Snow cover strengthens these inversions by reflecting sunlight and emitting infrared radiation, causing prolonged cold fog. We don't see that here. Effects of inversions. All inversions inhibit atmospheric mixing, leading to pollutant accumulation. Again, bad for us. Winter inversion can persist for days until a storm disrupts the stable air. In some cases, fog within an inversion reflects sunlight, making an inversion even more persistent. At the end of this chapter, there are still 2 concepts that I want to cover, which is, first of all, is fumigation. Fumigation, as you can see here, is an inversion that goes really bad. It occurs when a pollutant plume trapped under a ground-based inversion suddenly mixes with downward as inversion breaks up due to solar heating. So this is example, 6 a.m., strong inversion traps pollutants. 8:30, ground heats, the inversion breaks, the pollutant mixed to the ground, creating high concentrations for a very short period. can cause damage to crops and environment due to brief intense exposure. Fumigation also happens near shorelines when a stable sea breeze carries pollutants inland, which are later mixed downwards by ground heating. Another concept is the stagnation. That's when air masses remain in place for several days. That happens a lot in the eastern United States, where alternating warm, humid air from the Gulf of Mexico and cold, dry air from Canada meet. Leads to accumulation of pollutants, which can reach harmful levels during these events. Air pollution controls reduce the severity of this stagnation in recent years, but they still contribute to high pollutant concentration. And with this, we end the chapter about the atmosphere and its stability. Thank you for watching.